Hey y'all. Today's lesson is surface area of cylinders. So let me zoom out just a little bit. Okay, there. We've practiced surface area of prisms, rectangular prisms and triangular prisms. And surface area of cylinders kind of follows the same pattern. It's just not in the same category because they're cylinders and they have a few different characteristics than prisms. Cylinders and prisms both have two bases. So here is my pepper shaker. It's not a perfect cylinder, but there's a base at the top and a base at the bottom, and the base is a circle. So prisms have two bases and cylinders have two bases. What's different is the lateral area. For a prism, the lateral area, the faces had sides, and so you took the perimeter of the base. But for a circle, the perimeter, you can't do the perimeter of a circle. We have a different vocabulary word for the perimeter of the circle. And so that's what makes cylinders a little bit different. So let's just get some vocabulary. Surface area is the sum of all the faces. And we have a formula for surface area, and that is lateral area plus two bases. Sorry about that. The lateral area is the area that goes around. Now, in prisms, we said pH, the perimeter of the base times the height of the prism. And then the two bases, the base area. In prisms, the base area could have been a rectangle or a triangle for our purposes. We did rectangular prisms and triangular prisms. For a cylinder, the base area is a circle, and the area of a circle is pi r squared. We've used pi r squared in volume formulas, and we've done, I assigned, review on area of circles. Now, we cannot find, like I said, we cannot find the perimeter of a circle because there's no sides. So to find the distance around the circle, that is called circumference. So the perimeter, we can't find the perimeter. We have to find the circumference, and that is 2 pi r. Now, you could use pi d, pi times diameter, but the issue is you have to do the radius for the area, so it just kind of keeps it more unified if you just use the radius, because you have to find the radius. So this way, they both have the radius. And then when you put it all together, the lateral area, so this is the P. And this is the capital B. So when you put it all together, it becomes the perimeter, which is the circumference, 2 pi r, and then don't forget your h, because remember it's the perimeter times the height, plus 2, because there's two bases, times pi r squared. And that is the whole surface area. Now it's long. But if you notice, it starts 2 pi r, 2 pi r. And it's not something yes, you'll have to know it, but I don't want you to think I just have to memorize another formula. I want you to think intentionally. The perimeter of the base is the circumference times the height. Twice, because there's two bases, and the area of the base is pi r squared. Now, some common mistakes. A lot of times people will use the diameter instead of the radius. That's a common mistake. Someone will forget to take the diameter and cut it in half. Students forget to square the radius. Students forget to square radius. Or they just, another common mistake is they just forget their formula. But we're going to practice, and you will get this. You will get this. Example 1, determine the lateral area and surface area of the cylinder, round to the nearest tenths. So we're going to start with pH plus 2b. Now again, the perimeter of our base. So I'm just going to shade in the base so you can see. To find the perimeter of the base, we can't add all the sides. We have to do the circumference, which is 2 pi r. And then we bring down our h. Plus 2. So you notice I'm just bringing that down. Capital B means base area of a circle. And that would be pi r squared. Notice they both the front and the back start with 2 pi r and 2 pi r. This is the lateral area. That's the lateral area. Now we just need to plug our numbers in. We have our radius. So 2 pi, radius is 2, height is 7. So this is our height. Plus 2 pi, and the radius is 2 squared. So because it's asking me for the lateral area, I'm going to have to type this in separately. So I'm typing it in. So this part is showing your work. That is the part I expect to see showing your work. 2 pi times 2 times 7. So 87.96 plus 2 pi times 2 squared plus 25.13. Now notice I'm rounding to the hundredths, and then I'm going to do my last answer. I'm going to round to the tenths. So here's my lateral area, 87, and that would round up, so 88, about 88 meters squared. And then when I add these, 87.96 plus 25.13, I get 113.09, which means I'd round up to 113.1 meters squared. All right. Now, could you type all this in at one time? Yes, you could. And it'll give you your total surface area, but it won't tell you what your lateral area is. And so that's why I break it up into 2 parts. All right, let's do another one together. Determine the lateral area and surface area of the cylinder, round to the tenths. So again, I'm going to start with my surface area formula. The perimeter of the base, and here is a base and here is a base, so you can see it's 2 pi r times h. Bring down your 2. The area of the base area is pi r squared h. Pi r squared, not h, pi r squared. All right, the radius is 3 and the height is 9. The radius is 3 squared. Okay? So now this time I'm going to type it all in. I'm letting you see. I'm going to type it all in just like this. 2 pi times 3 times 9 plus 2 times pi times 3 squared. And this gives me my total surface area, 226.2, because I'm rounding to my nearest tenth. And that gives me my total surface area, but it doesn't give me my lateral area. So to find the lateral area, I just need to type in this first part. This is the lateral area. So 2 pi times 3 times 9 is 169.6 feet squared. All right. All right, so you try example 3. Pause the video, you try example 3, and then press play when you're ready to see it. All right, I'm just showing my work. And I hope you found, this is the diameter, so the radius is 7. And the lateral area is 2 pi times 7 times 10. 439.8 centimeters squared. And then I'm going to add that. So I'm just pressing plus. 2 pi times 7 squared. And the total surface area is 747.7 centimeters squared. All right, I hope you got that one on your own. Let me see how my time is doing. All right, so let's get into some word problems here. If you are not a fan of word problems, then just listen and hear my strategies and hear my thinking. A circular fence that is 2 feet high is to be built around the outside of a carousel. So we're talking about a circle, kind of like a cylinder shape, a fence that's 2 feet high. The distance from the center of the carousel to the edge of the fence will be 35 feet. So we have a cylinder type fence. And what did it say? It's going to be 2 feet high. And from the center of the carousel to the edge of the fence will be 35 feet. Okay, so this drawing is not drawn to scale. Really, it's a really fat one like this. Trying to keep all the kids in. Okay. Either way, it's not drawn to scale, and we have our measurements. What is the area of the fencing material that is needed to make the fence around the carousel? So we're talking about just the slats of wood that go around. Okay. Are they putting wood at the top or putting wood at the bottom? No, they just want the fencing to go around the carousel. So this round part is the lateral area. The top and the bottom are the bases. So we only want the lateral area for this problem. This problem is only asking for the lateral area. And the lateral area is the pH. The perimeter of this circle, we can't add up the sides, so we have to do 2 pi r h because we have to do the circumference. And then we put our numbers in. So 2 pi times 35 times 2. So the lateral area is 439 and 8/10 feet squared. That's how much wood is needed to go around the carousel. Sorry, my phone's buzzing at me. And the reason we did the lateral area is because they're not making a top or a bottom to the fence. The fence is only the middle part, the lateral area. All right, example 5. Determine the area of a label. Okay, circle the word label of a can of tuna. So tuna cans are kind of short, aren't they? So can of tuna with a radius of 5.1 and a height of 2.9. So tuna cans. Round to nearest 10th. The label. Where does a label go around a can? Now, I don't think I have a tuna can to show you, but I can show you. So here's a label. Now, it doesn't cover the whole thing, but the label only goes around the middle. Usually labels aren't going to go on the top or bottom. And on a tuna can, the label actually goes all the way around. So again, we only want the lateral area. These word problems are just going to try to be a little tricky because it's only going to ask you for the lateral area, or maybe it'll ask you for all of it. So 2 pi r h, and I know I just did the lateral area. 2 pi, the radius is 5.1, and the height is 2.9. Here is showing your work. That is what I need you to show me your work. And then I type it in, 2 pi times 5.1 times 2.9. And we need about 92 and 9/10 centimeters squared of paper for the label. I'm just checking my time. 92 and 9/10 centimeters squared of paper for the label. All right, last one. Determine the total surface area. So it tells you right here, total surface area of a cylinder candle with a diameter of 4 inches and a height of 2.5 inches. All right. So pause it, you try, and then press play. Now, because it's asking for the total surface area, I know I need both parts. My perimeter is really my circumference, and my area of a circle is pi r squared. Now I need the radius, and since the diameter is 4 inches, the radius is 2. And this is where I need you to show me your work. And then I'm going to plug it all in. 2 pi times 2 times 2.5 plus 2 pi times 2 squared And we round to the nearest tenth, and my total surface area is 56 and 5/10 inches squared. And that means, what are we talking about? Wax. So that would be if we wanted to cover this candle. Let's say we wanted to cover it with a label or we wanted to wrap it with wrapping paper. This is the surface area of that candle, and that includes the lateral area and the two bases. Okay, we will practice more with cylinders in class.